All right, hello everyone. So as mentioned before, we're jumping to the bottom of page 5, where we will conduct this formal hypothesis test. And so we're going to start just by writing the definition of the p-value, and then a lot of the rest of the video will be kind of on steps that we're taking to actually calculate it. And so the definition of this p-value is just the probability of observing data that is at least as favorable to the alternative hypothesis as what we actually observed. So that's already quite a mouthful, and we're not actually done yet. All that if the null hypothesis is true. So, like, yikes, that's like kind of a lot. So we're gonna shove that to the side for now and kind of break it down piece by piece once we get to the calculation part. And so in our example above, I'm just gonna rewrite what the null and alternative hypotheses were, just so that we have them. And so we had written these on a previous page where our null was that the proportion getting the question right was a third, corresponding to random guessing. The alternative was that it was something different than a third. And so now let's kind of go through first kind of some preparation steps and checking steps, and then talk about the actual calculation of the p-value for this problem. And so remember that our sample proportion is what we actually saw, and that was, what was that? And so our sample proportion was just the number of students who answered the question correctly divided by the total number, and so it was just 15 divided by 56. We could also write that as a decimal, which I'll do just because that will be useful when we actually draw our graph. And so it's about 0.27. And so just like for the confidence interval, we're also gonna, we also have a condition that we need to check to make sure that our hypothesis test is gonna kind of work the way it's supposed to. And so we're gonna do all this stuff assuming the null hypothesis is true. And so for now, we're assuming that people are just randomly guessing at this question and that the proportion actually is a third. We're doing that because that's what the definition of the p-value is. It has this kind of clause at the end that says if the null hypothesis is true. So for now, we're assuming it's true. Assuming it's true, we can check the success-failure condition. And so that is about 18.67. And 37.33. So both of those are greater than 10, so our success-failure condition holds. Again, we're assuming the null hypothesis is true, so that's why we're plugging in p naught here instead of p hat. Because all this calculation stuff for our p-value, we're assuming the null is true. Also, we're just going to say independence holds. Again, we've got plenty to think about right now, so we will push that aside to later. Okay, then we did all of that work with sampling distribution, so we spent all that time on that to know that if these conditions hold, which they do, then our sample proportion will be normally distributed with mean p and standard deviation calculated from the standard error formula. Again, since we're assuming that the null hypothesis is true and that the proportion is a third, then the sampling distribution is going to have a mean of whatever our null hypothesized value is, p naught, which is a third. Again, because we're assuming that the null is true, so we're assuming that the true proportion is a third for now. And a standard deviation, which remember we just had that special term standard error to refer to the standard deviation of our sampling distribution. That's going to be, if we're assuming the null hypothesis is true, then p naught gets thrown in for p. And so you should be able to figure that out just on your calculator. So it's probably, if you're kind of doing this, easiest to do everything inside the square root and then take the square root at the end. And so we should get that as our standard error or standard deviation of the sampling distribution because they're the same thing. Okay, and so then we could draw our sampling distribution under the assumption that the null hypothesis is true. If the null is true, then it's going to be centered at a third. Just to really emphasize this is our sampling distribution if our null hypothesis is true. It does say that there as well. And so it's going to be centered at a third. The standard deviation is 0.063. And so what I'm going to do to calculate my first tick mark is I'm just going to do a third plus 0.063. To get the second tick mark, I'll add 0.063 again. And so it looks like here we've got 0.396. Here we've got 0.459. In the other direction, I'm just going to subtract. So we did that work with the normal distribution is now paying off here, where we could draw this sampling distribution. And now what I'm going to do is mark where our sample proportion that we got from data falls on this distribution. And so again, this is just the sampling distribution of p hat if p is a third. And so the data that we actually saw actually falls right on this 0.27 exactly. And so now we just want to answer this question of what does this mean for how likely it is to obtain our sample proportion of 0.27 if the null hypothesis is true? We did that work with the normal distribution, thinking about how extreme things are based on where they fall on this distribution, with things closer to the tails being more extreme. And so how extreme is it to see what we actually saw in our data if people are just randomly guessing? We'll answer that question in a sec with an exact probability, but what if our sample proportion had been 0.57? So kind of way over here is 0.57. take a second to think about whether that would be more or less extreme than what we actually observed if people are just randomly guessing. Based on what we did before, talking about the normal distribution, that's more extreme because it's way more in the tail. So more extreme, 0.57 would not be very likely if people were just randomly guessing. 0.31, which falls about right here, that looks like it's perfectly reasonable if people are randomly guessing. That's really near the center of this distribution. And so 0.31 compared to what we actually saw would be less extreme. So 0.31 is perfectly reasonable / likely if p is actually 0.33. So it's really not that different from 0.33, so that should make some intuitive sense in that way as well. What this p-value then is just going to formalize this concept of like a likeliness, assuming the null hypothesis is true, by calculating a precise probability. And so I've already crossed my usual 10-minute threshold, and so we'll go ahead and save that for the next video. Just as kind of a gentle reminder that we will be doing this hypothesis testing stuff a few more times. It's probably not all gonna click the very first time, but the more we see it, the more practice we'll get, and the more this kind of reasoning should make some sense.